We are one of the cleanest steel producers in the world. Thanks to our dedicated employees, we're also one of the safest in North America. We're not only passionate about steel, we're passionate about exceeding our customers' expectations by producing world-class quality wire rod. Let's see how it's done. IVACO Rolling Mills is a combination of a mini mill operation that produces over 200 unique chemistries of steel billets and a rolling mill operation that converts billets into 39 distinct wire rod diameters. A mini mill is a steel plant that uses scrap as feedstock for producing new steel. The scrap is recycled from different sources such as old cars' bodies, household appliances, demolition material, as well as other consumer and industrial products. 8 distinct types of scrap comprise the more than 550,000 tons of scrap recycled by IVACO rolling mills each year. The scrap is carried through the Consteel continuous charging system before being melted in the 115-ton electric arc furnace. 78 tons are tapped from this furnace, creating a unique heat of steel with specific chemical properties. This is done by adding carbon and various types of alloys to the furnace. The liquid steel temperature inside the furnace can reach up to 3,050 degrees Fahrenheit through high amperage, low voltage power, passing through the electrodes and creating an arc into the steel. Oxygen is also blown into the furnace to generate heat. Once the expected chemical composition has been met, the molten steel is poured from the furnace into a ladle before being moved to the ladle metallurgy furnace. At this stage of the process, chemistry is thoroughly tested and refined through the addition of carbon and various alloys being stirred with gas to ensure homogeneity. When the precise chemistry and temperature are obtained, the ladle is transferred by crane to the continuous casting operation. The steel is poured from the ladle into the tun dish, which is a reservoir used to deliver molten metal simultaneously to the 3-strand high-speed billet caster. IVACO Rolling Mills is capable of casting steel using either open or submerged continuous casting process. The production path is chosen based on the required quality and the grade sensitivity to oxygen contact. Each strand is slowly drawn downward through a curved arrangement of support rolls, as a water cooling spray system helps solidify the steel, forming the shape of the billets. After emerging horizontally from the discharge end of the caster, the billets are straightened through a set of rolls and cut to length using oxygen torches. While moving along the cooling bed, each billet receives a unique ID that will facilitate its tracking and later conversion to wire rod. This is where the billets are coming to life, already assigned to a specific customer, awaiting to be converted to wire rod. At this point, billets are stored in the indoor billet yard, slowly cooling down and awaiting transfer to the rolling mill. When required, billets are picked up by the crane and delivered to the charging table, where a final check is done to ensure full order traceability. Each billet moves along a roller line to enter the walking beam reheat furnace, where it reaches an internal temperature of approximately 1,150 degrees Celsius. For the heat to soak uniformly all the way to the billet core, the residence time in the reheat furnace is approximately 90 minutes. When the billet emerges from the reheat furnace, 2 sets of rotating arms are used to transfer the billet to the breakdown mill. At this stage, the billet goes through a reduction at each of the breakdown mills' 4 stands, which converts the 160mm square billet into a longer 105mm round bar. Coming out of the breakdown mill, the bar is then directed to one of 2 strands where it transits on its way to the roughing mill. As the bar progresses through the roughing, pre-finishing, and finishing mills, depending on the final rod diameter, the bar can pass through 24 sets of rolls, its cross-section being progressively reduced and its length increased. Through the production process, the rod also passes through enclosed water boxes to uniformly cool down the steel and to obtain optimal internal structure, which varies based on the customer specifications. When the rod exits the finishing mill, it moves to the final reduction stage at the reducing sizing mill, comprised of an additional 4 sets of rolls. This will give the rod its final dimension, from 4.75 millimeters up to 25.5 millimeters. Wire rod diameter, as well as surface defects, are measured through various instrumentation to ensure it meets exact customer specifications at the end of the process. Finally, the wire rod emerges on the Stellmore cooling deck through the rotating laying head, which shapes the rod into a coiled pattern. The linear speed of the steel rod can be as high as 100 meters per second at this point. After cooling on the Stellmore deck, the coiled rod falls into a reform tub to be collected as a neatly shaped coil, before being transferred to one of the 50 hooks of the coil conveyor system. Every coil is thoroughly inspected as far as grade, diameter, ovality, as well as surface defects and mechanical properties. It can also be tested for tensile strength when required. By the time it reaches the end of the production line, each coil has been trimmed, shaped, tested, compacted, weighed, and tagged in accordance with the industry's highest standards. As all operations and inspection criteria have now been completed, the coil is transferred to the walking bed conveyor to be moved outside of the plant. The forklift operator then transfers the coil to its predetermined location in the yard, ready to be shipped to one of IVACO Rolling Mill's customers across North America. By transforming steel scrap into liquid steel, then billets, and finally wire rod, the IVACO brand means exceptional quality and reliability. Every worker is committed and dedicated about their impact on the finished product, day and night, 24/7. We're a team you can count on.